Okay. Yeah, okay. Look, too loud, too soft. Okay. Is it back on again? Was perfect half a second ago. And we're back again, are we? All right. Well, that maybe it's the wind. I've got no idea. If okay. So okay, I was just saying that the booking sheets were fine. Everyone went well in it. You might think that you don't these assessments that you're doing or these activities you're doing don't get looked at, but I look through them every morning, and I'm looking for people that are getting 8s and 9s and 10s, and that's really good. Uh, the odd ones that get 3 or 4, sometimes when I have a look at those, it's because they've just made one simple little error, which I do as well, and most other people do. So it's not that bad as long as you're building up an understanding of it. All right. So for all those people that are fretting about making a mistake, don't worry. If you improve and you know where your mistake is, it's all good. Now, what we're going to do to try and we've only got a few activities tonight. When I say a few, we're going to finish. We've got another contour plan from height of collimation sheet to do, but this one's easier than the one you did the other night. The other thing, yeah, there was an error in the quiz from the millimeters. Yeah, that's correct. There was. I apologise for that. That was mine. My meat fingers hit the wrong key, and it dominoed from there. But yeah, so look, like I said, you've got to build an understanding on doing these sheets. Okay, just with this, we looked at this the other night, and I'd like to look at it again. And it was this. It was the PowerPoint that. Okay, I'll go back. It was the PowerPoint that I had, and what a contour plan allows you to do. The contour plan allows you to design your stormwater, and you had that in the quiz, and we'll just go through this. This was that one I said was there were 63 slides, and there was only actually 7, if everyone remembers that. Okay, that was the plan. This is the contour plan. Okay, this is this is the contour plan. Now, the next thing that happened from that was the design. So in this design, they've elected to go into the hill. They've elected to design the house so there's a garage and entry underneath the house. So this is why you're building you have a contour plan. This height here was around 3.6 meters, 3.4 meters, I think it was. So that's a heck of a long way in, and that was a heck of a lot of soil that came out of there. And you can see the house was designed for the side of the hill. Okay, you've got a maximum height of 9 meters. Okay, so this had a skillion roof on it, which was about 8.8 meters, nearly parallel with that driveway there. Okay, so the architect actually designed the whole house to suit the block, and the contours play a big part in that. All right, now that's the main thing with contours. I just wanted to show you two other items as well. Okay, we'll go with this one. Okay, this is another one. If we look at this, hopefully you can see it. Okay, this is a preformed estate. So, okay, they've got different levels here. So you've got to design whether you actually excavate into the hill and put a garage underneath it, or do you go over the hill? You know, and what are the advantages and disadvantages of going into the hill or over the hill? Well, there's advantages and disadvantages in both. If you go over the hill, you're saving the money on excavation. If you go, but you've got to actually build the house, you've got to have something underneath the house. But by having a section of the house raised off the ground, it has room for water tanks and some storage. So, you know, for my way of thinking, I'd rather build with the hill and not go into the hill myself. Okay, so that's just that. There's only a couple of photos that are okay. That's the house. The house never went any further into the hill. It had a garage in front of the hill and then went over the top. No more excavation was required. Okay, now other houses in this estate went further into the hill. Okay, they wanted a deeper section in there, try and extend the house. But okay, for things like that, it costs more money. It can cost more money. It depends on the design. Now, that's just another photo of that same house, but you can see the land, the reason for contours. Okay, this is the reason that we have contours. Okay, it's not specifically the reason why you're drawing contours. I've never, bar at TAFE, I've never drawn a contour. Okay, tell a lie, I've probably drawn one. But I knew what a contour plan was and I understood it. And what you people will get from doing this, you'll get an understanding of why you need a contour as well. There's one. Okay, this is another one. This is just another block of land. How do you design a house? Okay, if you look at this, that's on the other side of the road up there. But this has maybe a 3 meter fall in the land. Okay, so there's a house that goes on that had a contour plan with it, and all these blocks have contour plans with them. You need a contour plan to design your house. Okay, now the wash up for that one there was the house from that last block of land. Okay, yeah, it didn't go into the hill, it went along the hill. Okay, there was no excavation for a garage, and yet you could excavate for a garage if you want. Okay, if I could show you this house around the corner there, they excavated underneath for their garage. So contours play a really, really important part in the building process. As I said, if you looked at this place here, there was virtually only the footings were excavated. There was no excavation for the slab. There was no basement area. There was nothing else. So it actually followed the slope of the land. It had a maximum height. Okay, that height there couldn't exceed 9 meters, and that height there couldn't exceed 9 meters. But you could follow that 9 meter slope of the land. Okay, the same with that other place, and that's a contour plan for you if you're going to start designing houses or building houses or renovating a house that you already own. You've got to be aware of what you can actually do with it. Okay, now I'll just go back. One thing tonight, we've got 3 films, I think, and I'm going to try and get through the night by showing them all before I actually start them and have to go back and reopen them. That's my goal for tonight. So I'm going to actually show a few things now. You've got a couple. That was most of our theory, because a lot of it's going to be your some exercises. So we've looked at. Okay, what we'll do. This is the first thing. This is just excavating. It's a 3-minute film. I don't think it's 3 minutes. I think it's 2.5 minutes. And it just shows excavation and why we actually need to know levels, why we need to know contours. Okay, so what I'll do, I'll show it as opposed to not showing it and forgetting about it. I'll show it to start with. So I'll see everyone back here in 2.5 minutes. If you just show me, write in that you're done. All right. So mute that. Okay, hopefully sound, can you hear me? I've just had to plug it in, so it's a bit of a lucky or unlucky process. Nobody can hear me? Okay, can you hear me? Okay, that's good. You can hear me. Good. Okay. All right, look, that just shows you excavation. Now, what would happen with a job like that is you would have a benchmark out the front on the road, and the only way they can actually determine how deep that excavation has to go, it's got to go below the concrete slab. It has to have a little bit of blinding sand on top of it. So the only way they actually determine the depth of the excavation is by benchmark out the front. They take a reduced level on site and they say, okay, from this reduced level, we've got to be 3.1 meters to the bottom of the trench. Okay. And that's how they determine when they put those piers on the side to retain both blocks of land on either side. The reason they did that, they knew the depth of those piers because they knew how far it was to the bottom of the concrete. Okay, it wasn't guesswork. They bored it down to a certain depth. Okay, now, so that's part of what we're talking about on site. You've got to know you reduce levels. You've got to know how to determine a level on site, uh, and you've got to be able to relate contours to the plan. Okay, one, you can start with a contour plan and design something, or two, uh, you might just have to have a contour plan and see if you can find a house that can get built on there for you. Now, we've got one other film to do. Now, this next film is 3 minutes and 3 minutes and 22 seconds. Okay, this is what you're going to be doing next. Okay, so you're going to calculate the volume from a sloping block, how much soil is going to be excavated. And it's only an approximate, it's not an exact science, but it's pretty close to being, you know, what would be excavated on a site. So what I'll do, I'll show the film. So I'm shooting for 100% tonight, or better still, I'm at 100% tonight. There's the film. I'll come back if you can just actually let me know when you've finished watching it. We'll just have a look at this film, then we'll come back and talk about it, and then we'll open up the activities. So What about now? Okay, how's that? We're on. Okay. All right, look, it's no more difficult than that. If you follow the format, keep your decimals. If you look at this here on your screen, if you start dropping decimals off, it's just such a good practice to get into to keep your decimals in line. Okay, everything there's in line. All right, you can look at that. That one's there as an example. So I'll just go through and start opening everything up. If everyone can just tick the attendance choice, I'll just go through. And so the first thing you've got to do is a continuation of what we were doing on, or what you were doing on Tuesday night. You'll do a contour plan from a height of collimation and rise and fall booking sheet. Then there'll be an activity to go with it. You've got to upload your work. So okay, anyone that wants to start, there's an activity. If you want to refresh your screen now, there's one you can get started on while I open the rest of them up. It's really important to complete your booking sheet so that if you make a blue, we can have a look and just see whether it was just a simple slip of the finger or whether you're just a little bit unsure or unclear on how to go about it. So that's it for the learning content tonight. There's no more learning content. There's the films there or one film there to support your calcs, and there's also some examples there to support your calcs if you're not sure. And as well as that, there's Frank, Adrian, myself, Stuart, Brett is probably there somewhere as well. And look, as well as that, keep checking your assessments, everyone. We've finished marking assessment 7, and there are still some students that need to resubmit. So check your feedback. If you've got, even if you look at it and there's nothing there, just check your feedback, because sometimes that's how Moodle shows that you haven't been successful. It'll just show nothing. So check your feedback. Okay, as well as that, tomorrow night's our prac night. So anyone that wants to come in on, I'll be there from 5 o'clock. Not tomorrow night. Next week is our prac night. Next Tuesday. Next Tuesday is our prac night. So anyone that wants to come in from 5 o'clock on. Okay, Han. I've sent messages to ask if something can be reopened again. What one was it, Han? Specifically. Okay. Alan is assessment 7 in legal. What does the Pracnite entail, Jacob? Okay, it's just setting up the leveling device. It's doing a 2-peg test. It's taking levels and just recording them. Um, it's doing an inverted reading. It's just giving you some experience on what you'll be doing on your field day. Uh, you can, yeah. Look, some people might be there at 5 o'clock, and they might be gone by 5:45 or 6 o'clock. Some might come in and say, "Oh, okay, I know how to do this. I don't need to."